Good. Okay. What I'm going to do now, I'm going to talk for 15 to 20 minutes and fill in some of the pieces that and add to some of the pieces that Ivan offered us. And I wanted to start off by going back to in a bit more detail to the question of where onshore. And first of all, it's very clear that there remains conventional exploration onshore, conventional traps, conventional reservoirs, conventional oil and gas, and so on. And that continental interiors where we've not been able to deploy in modern technology will be opened up for conventional exploration. For example, the middle of Africa, the middle of South America, East Siberia, and so on. And then you get the old concept of new geography, i.e. countries that have been closed for a while for some reason. Libya is an example. At our last forum in February, one of the countries we looked at is Libya. And it's pretty clear that if the security and political situation in Libya improves within the next 12 months when they have a new constitution, which they should have or will have, then there remain significant opportunities for frontier exploration, development of existing discoveries and so on, all of which have to a large extent been passed by current technology. The same is true of a company like Myanmar, which is going to open up and is planning licensing rounds and so on. Actually, not just onshore there, but offshore too. So one or two countries that are opening up. But actually, I want to focus today on unconventional resources. And the next picture is a map rather similar to the one that Ivan showed in his talk. I have to say, you'll have seen this map before if you came to our Unconventionals Forum in October. This was presented by Kimmeridge Energy. Kimmeridge Energy are a fund-based startup, I suppose is the right way of putting it, based in New York. And they're investing in 3 or 4 different plays in North America, US and Canada, and now moving out internationally. They had they started off as an offshoot of Bernstein, which is the research house and brokerage, and that didn't particularly work very well, and so they had a hiatus of about a year, 18 months, 2 years, where they did a huge amount of studying of the global onshore picture, and beginning to ask the question, what's the potential for unconventional resources in onshore basins outside the US? And you can see here, I mean, this is their number, not mine, and I'm not going to claim ownership for it, but huge numbers, and broadly speaking, saying that the prospective resource in unconventional shale gas and shale oil is equivalent to everything in the world that's been found and conceived of in conventional oil and gas fields. So very, very large numbers is perhaps the takeaway point. In particular, I want to use another of their slides, which is this one, just to go from the general principle, which I'm sure you're all aware of, that shale oil and shale gas is founded on the idea that when a source rock matures, clearly some of the oil seeps to the surface, some of the oil is trapped conventionally, some of the oil or gas seeps to the surface or is trapped conventionally, and some of it stays within the source rock. And one of the numbers that's always been elusive and indeed the subject of dispute between geochemists is, well, how much actually stays in the source rock. And this is a number that, if you ask the BP geochemist this back in the mid-1980s, in the days when the geochemistry branch was run by a guy called Andrew Mackenzie, who's just become chief executive of BHP Billiton. He would say 5% remains in the source rock, and that was based on organic geochemical modelling, basically. What Kimmeridge did in this 2-year hiatus, when all they really had was each other and no money, was study every conventional play in the world, basically, every conventional source rock, and concluded that the number was much more like 50%. So that, you know, if you took everything you knew about the productivity of a source rock, drove it through the oil and then the gas window thermally, and then looked at how much had been generated, how much you could prove trapped, what the upside of that conventional trapping was, how much you could demonstrate had got to the surface, and how much was left because you can sample it with some boreholes. The answer is probably typically half stays in the source rock, or very close to it, rather than escaping in the most general sense of the word. So that's a change in scale from what I would have said. Personally, if somebody had asked me 5 years ago, I would have come up with the 5% answer, whereas 50% staying behind is a big number. So that is the core idea here. And what that does is move you away from the, and as it says here, from the relatively low success rate, you know, 1 in 2, 1 in 3, etc., of finding conventional traps, to actually oil and or gas is retained more or less everywhere in a source rock. It may be as much as 50%. There will be sweet spots, and the key is to find those rather than to find a trap. And then to understand if it can be produced at commercial rates. Now, when you start thinking about, you know, I've had a sort of consultancy role with Kimmeridge, and therefore visited some of their the people they use in the States to do their work on the various US and Canadian basins that they're involved with. What you observe is that the style of working in the US, particularly in unconventionals, is different from the style of working in the modern seismic-dominated offshore oil and gas major, or E&P for that matter. Very different, and I'll come on to how it's different in a minute. But it comes to the question then of how, you know, what's happened here. There's a kind of mental assumption being made by lots of companies that, oh, this is exportable to South America easily, this is exportable to Africa easily, this is exportable to Europe easily, to Russia, to Southeast Asia and to Australia in particular. And I would say not true, and we have to think very carefully. And the reasons, and just the logic behind that in a bit more detail, if you pick up, you know, you have the opportunity that I did this morning to sit on one of the 10 most crowded trains in Britain and come into Paddington, and First Great Western obviously believes that giving you a copy of the Times is some sort of make-up for having somebody sit on your knee. The Times as and is typical of the media, and when talking about shale gas and shale oil, they've tended to focus on the interesting issues, like does fracking cause earthquakes, does fracking and the use of gallons and gallons of water cause pollution, and so on and so forth. So the focus has been over there. If you look at the industry, if you read Oil and Gas Journal, for example, or indeed, you know, you look at Baker Hughes's website or Schlumberger's website, their focus is on there's a lack of infrastructure, the politics on the ground are different, there's no drilling equipment, you know, there's 50 rigs in the whole of Europe that can do big fracks compared with 1,500 in the US and so on. So they tend to focus on those things. What I'm actually saying is you have to, really, if this is going to work, you have to start somewhere else, which is on the economics, which leads you to the question of sweet spots. Because, and again, this is not my work, this is other people's. If you look at every single unconventional play in the US, and there's a lot of them are quite mature now, i.e. been going for a while, there are core areas and non-core areas. And if you're not in the core, if you're in a non-core area, you're losing money and your shirt and everything else. If you're in the core area, then you've got a viable proposition. So very important to figure out where the core of a resource play actually is. And in the US, when you go and talk to the army of consultants that's working on the Illinois basin, and you ask them how many wells they have, they say, I can't quite remember, it's either 21 or 22,000. And these are all high quality wells, fantastic quality well logs, and they can access them all through the state surveys. So the modus operandi in the States is geochemistry, sedimentology, paleontology, et cetera, et cetera. And in fact, I asked one of the lady who was running this consultancy when she looked at the seismic line, last looked at the seismic line on the play that they were looking at, and she said, we don't have one in the building. This is driven by old-fashioned geoscience, doing old-fashioned stuff, geochemistry particularly, but paleontology, sedimentology, stratigraphy, etc. And you can use the word old-fashioned in a couple of different senses, actually. So the question comes then, and just as a, this isn't new news. I mean, US companies used to work like this 25 years ago when pursuing conventional fields, that they were much less driven by seismic, much more driven by well data. Well logs, cores, cutting fluid samples, and so on. And it's one of the reasons why in the 80s so many US companies set out to move overseas and failed. And the reason it failed is because there's no data, which is kind of Ivan's point. So to move on, you need the old-fashioned geoscience. This is exactly what's been neglected in Western oil companies. If you go back 20 years ago, and I can only talk about BP, but I'm sure Shell and others are the same. BP had in Sunbury a geochemistry branch, a stratigraphy branch, a sedimentology branch, a collecting cuttings branch, a flowing mercury through cores, et cetera, et cetera. None of that anymore. Because of the dominant offshore, of offshore, especially deep water exploration, we've actually become a race of 3D seismic dominated. The world exists through twin-headed Dell workstations folk. And we're not equipped yet to do this in a skills sense. And what's more, the data anyway doesn't exist. Because if you go to Australian basins and ask them, okay, Australia, democracy, good economic terms, good above ground risk, how many wells do you have in the Canning that speak to this problem? The answer's 10 or 12, not 20,000 or 22,000. If you go to China, let's say, they may have 5,000 wells, but they can't find them. And probably if they can find them, they won't give them to you. So the international world is different, and therefore it depends on, first of all, the skills of the people, which we've allowed actually to atrophy. You still find groups more independent of oil and gas companies that have them, but big companies don't have these skills. And sort of speaking against the point in a way, even if they did, the data doesn't exist, or not in enough quantity. So again, I'm not going to tell you because I don't know the answer. I mean, my opinion is that when you're talking about things that depend on a logical evaluation chain going from spotting seeps to understanding the connection of seeps to source rocks to understanding where the source rocks are physically in the subsurface to then understanding where a sweet spot might be in the source rock. And remember, you've got to do all that to get in the right play that's productive enough where the numbers are 50% and not 5, and then drill economic wells. You can't say, oh, we'll just do this bit. You've got to do the whole chain. Then you're talking about a set of technologies that range from satellites through aircraft, through people walking on the ground to seismic. And I'm not saying I know a company that does it because I can't point you to an example. Or maybe PetroEnergia is a good example. The other thing is when you've done all that, it's not clear, I think, and I speak as a humble geophysicist, it isn't clear how you take the vast experience we have at looking at and trying to predict lithology and poroperm and fluid, excuse me, fluid content in sandstones and carbonates and translate it to shales. If you do a literature search on the internet, you can find a few companies that have written papers about it, that claim to do it, and they're interesting reading, let's say. But I don't believe any of them at the moment. So there's a long way to go in getting the technologies that will deliver this. So now at that point, I'm going to, and as I say, I've not yet seen a story, heard a story that says, this is it. I just haven't seen it yet. Now I'm going to move on, and this is slightly more flippant, but not completely. If you are, again, a sad person like me and have lost your British Airways gold card, and therefore you have to sit outside the Starbucks in JFK in New York waiting for your 8 o'clock in the morning flight back to London, what you'll notice is that things like this are on sale in the duty-free, $299. So these are unmanned, these are not toys. These are unmanned aerial vehicles that are controlled. You can see the guy there actually has an iPad controlling it. You can control one of these from an iPhone. And as I say, you can buy them $299. They come equipped with 3D high-resolution cameras. So you can, I'm thinking of getting one of these to patrol my back garden so that next time the person who stole the engine off my boat has a surprise. But there's already a company in Scotland that is using these to inspect offshore installations. I mean, the resolution is such that you can see rust on the top of a derrick with one of these. Now, that's not what I want to talk about. Gary, could you run the next film for me? It just, some of you will know I have a connection via daughter and son-in-law into the Air Force, and therefore I know a little bit about the next topic. These little things, of course, are drones. And these are this is a drone, a UAV, as they're known. And I just wanted to show you a few minutes clip. This is driven by a propeller at the back, unmanned, controlled from the ground, actually controlled by satellite. So it's a bounce up to a satellite and down again. This is the sort of image you can produce. This is a nighttime image of people trying to cross the border from Mexico into the US. You can get to a level of detail where you can see they're all carrying rucksacks. So these are pretty precise pieces. Maybe a hammer or two, but yeah. Yeah. And this is a vehicle. I'm not trying to have a moral discussion about whether this is right or wrong, but this is just what you can see. This is pitch black at night, infrared, camera, etc., etc. So you can pick out a lot of detail. The sort of thing that it'll move on in a minute to an image of the land-based, that's where it's being flown from. I think this is the sort of screen that the observer, what you call a navigator or the weapons systems guy, You can see this is from the US Customs, though, not from the Air Force. So he's got a map with his, this isn't the pilot's, this is the navigator's display, and an image of the coastline. So you can see he's flying along the coast, he's where the red dot is, and here they are coming into land. The real point of this is to get across to you the size of these things, because I imagine they'd be about this big. And you watch this thing. When he starts taxiing. So these are the size of a small executive jet. So you can put in these sensors, cameras, gravimeters. You can pack them with stuff. Now, which was the first country in the world to invent the jet aircraft? Germany. They think, anyway. This is a German jet version. So this is jet powered. These things will fly 24 or 36 hours, unmanned, from the ground. And again, the whole point of this is size. Look at the size of this thing. Yeah? I mean, this is the size of you get in this as a passenger. Yeah? Well, it may only be 6 of you in it, but these things, therefore, are capable of continuous operation, covering grounds that took our man on the horse days and days and weeks to cover in a few days. Packed with equipment, packed with sniffers, sensors, cameras, gravimeters, and so on. And somebody, and I've had a couple of conversations with, let's say, American defense contractors who are saying, yeah, we're going to make these into a commercial geoscience, environmental science vehicle, and these things are coming. And for onshore, it might be a good idea if we figured out how to use them, I think. Okay, enough. Anybody got any questions on the, because that's really the introductory piece from Ivan and myself, talking about onshore and the sort of technologies. Any questions about that? That's all. Okay, not. Very good. Right. Where's David?